to talk today about two topics that are important in the course, in one case at the very heart of the course. And the latter one concerns this issue of testability and designing for testing. You'll find these slides on the Canvas site. I'm going to be talking about different aspects of designing for testability in terms of process, in terms of formal specification, in terms of sort of innovations in the form of test hooks and other components that can aid testability, and with an eye towards your projects. In a way, you could view this as an element of risk management. One of the biggest risks for software development projects is hidden quality problems that aren't identified, aren't pinpointed by quality assurance processes. And that includes peer reviews, including inspections, but also testing. And testability can make a huge difference in making your project able to be tested effectively and in a rigorous and fruitful way. I want to situate this though here in this with the realization that the process of testing, well, we think of it as, trying to locate bugs in the system, trying to find defects. And while that's a big part of it, it's really a broader mandate towards finding quality problems. These could include not just, functional elements of functional design, the features that don't work that we think about, but usability problems. Right? Cases where the system is unpleasant to use, confusing to use, cumbersome to use, etc. In many ways, testers are the first power users of the system, put the system through its tests. And you should be looking for that actively, gather that information. That's not just ephemeral sort of things they notice while doing the real job of finding bugs. It's actually really important feedback to have on a system. What testers find by banging on it, right? By pushing it, by trying things out on it. Get that feedback in place for your teams. As far as finding bugs are concerned, that is a major component. And really what we're trying to do here is find important bugs. Okay, I'm trying to locate bugs that are that are likely to be really impactful, or they could be high severity, low priority. They could be high. They could be in many cases low severity but high priority. When I say severity or priority, can you give me a sense what I mean? Yes. So, okay, Tyler. Yes.
I assume what you're referring to is how much will it disrupt the functionality or just disrupt the user?
Mm-hmm. Yeah. So severity would indeed be how much does it? Good description there. How much does it? Is it disruptive of, or does it damage the user's experience and the user's ability to derive value? Right. To what degree does it take away the value delivered? Can you give me a really severe type of bug? Yes, Leaf.
It delivers a plug into your. Okay, no. I guess more seriously, you run sudo rm-rf star.
Yeah, that would be really bad to delete the contents of their drive or something. That's negative value delivered, right? You're taking away value. And that is an important class of defects. And I'm impressed that you suggested that one off the top of the head, because can anyone else mention a common one we think of when we think of high severity? like something that gets in way of the user's experience, yes, why an authentication problem, yeah, it can prevent them from logging in, or that, you know, someone could get in without being supposed to log in, right? Which is a security risk. But especially preventing them from being able to log in, or an authorization problem where they can log in, but they don't have the requisite permissions to do things. Yes, SIEM? SIEM. Never. Yes, thank you.
Bugs in the UI.
Okay, bugs in the UI can be high severity. Could you give me a bug in the UI that might be high severity?
Like, for example, sometimes buttons might not be accessible, or like, for
Okay,
example, when you sort of
Yeah.
you have a full screen, you minimize it, and so
yeah,
if this, for example, the CSS design is not done, when you minimize the screen, right?
Mhm.
Versus something that's on desktop, but then you try to use it on the phone.
Mm.
So
Okay, yeah, I mean, that can get in the way of user experience in significant ways. Certainly if the UI freezes up, so you can't use it, right? You know, what we think of as a freeze, a hanging of it, right? Where it becomes immobilized. And I think we've all dealt with that before with web pages gone awry. I'm struggling here. Yeah, give me another 10 seconds. 30? Yes. Memory leaks can end up, if they accumulate, they can end up being fatal to the system's ability to continue, right? And they can end up basically leading it to be unable to allocate more memory and therefore sometimes crash, right? So all those are good. I want to go back to leaf. So excellent. Thank you. I want to go back to leaves. Because we've highlighted the risk that you deliver negative. And yes.
that was an actual bug that happened, I believe, with the Steam, with the Linux version of the Steam client when it was uninstalling something.
That is very bad. Yeah,
Yeah.
that is very severe. Yes, thank you. Other things of that ilk would include data corruption problems, right? Problems where data is corrupted. You render a document that had been working unusable, right? It delivers negative value. You're taking away the ability to do something for the user, right? Actively taking it away. Or something that renders the system in a state it can't start again. You know. Okay. Good. So those are high severity. No question. Could something be high severity but very low priority? Yes, I see a Loganite hand.
Variety.
Sorry?
F variety.
F.
Logan.
Okay, yes. The F variant of the Loganian command. Yes, Logan. Keep on.
You could have a situation that is very obscure,
Yes.
very hard to run into.
Yes.
Affects almost nobody, but
Yes.
seriously detrimental to that single person.
Yes. It only happens on iPhone 9s, which, you know, have an unusually low memory configuration from 10 years ago or whatever. Yeah. So, or it's an exceptionally rare combination of circumstances that are infinitesimally likely to occur. So yeah, you can have that. Could you have something that's low severity but high priority? When we're talking priority, we're talking about importance of fixing, or sometimes the urgency of fixing it, but the priority of getting it resolved. Could there be something that is low severity but high priority? Yeah.
It's like any bug that you're constantly running into, but doesn't stop you.
Good.
Doing what you want. It's just kind of annoying.
It's annoying. Yeah. Anyone else? Embarrassing. Things that are going to make the client look bad or give them a bad experience. So this is certainly possible. Something that's just horribly ugly, right? Maybe low severity, but it gives such a bad experience to the user. It doesn't deliver negative value. It doesn't stop the system. It doesn't render it unusable. It doesn't block whole areas of system functionality, but it does make it unpleasant. Yeah, and generally that would fit into there. Okay, so testing can identify usability issues, right? And they can give feedback on rough quality of the system, like how soft is it? How good is it to use? How, to what degree this inspires quality on the part of that it's going to be reliably able to deliver. That could include long delays. It could include sort of odd updates visually. It could include some inconsistent results that lend one to wonder if there's a broad underlying class of bugs there. Okay. A key issue that I do want to highlight here, and we're going to start to talk about testability here, but a key issue you should be asking whenever you find bugs or you find issues with requirements, etc., you should be asking, I'm going to repeat this many times, but I want to drive it home. 2 questions. Number one, how can we lower the chance of this happening again? Number 2, how did this slip through our cracks and get to this point? Why was this not caught earlier? Right? How did this only come about? We found it now. And you say those without recrimination. It's not pointing fingers. It's trying to ask, how can we do better in the future? Right? How can we do better finding things, identifying things? How can we do better preventing things? And if you can keep that question going, not only at a technical level, at the level of process, right? Like the process you're running, like how did it not get spotted in peer review? How did it not get spotted at time of pull review requests, right? As an example, how did it not get spotted in the form of testing? You can actually really improve your system. You can really improve your game, and you can improve spreading of knowledge across the team, etc. I'll come back to that at different points in this course, but I just want to highlight. Okay, so testability is about making our system easier to test, rendering it so that it's more readily and more thoroughly tested, more reliably tested. And here, it's a reflection of the fact that if you're not proactively, consciously trying to promote the ability to test your system, the chances are that it actually may be challenging to effectively test some components. Systems often have a lot of state that's underneath the surface. It's not directly shown in the UI. You can't directly interact with it, but it makes the UI actions possible. And it's really valuable if you can effectively test that underlying consistency of the state of the system. By the same token, as you're trying to debug the system, trying to determine the cause for errors, being able to effectively probe the system's underlying situation is really, really valuable. And testability aids in that debugging as well as in the testing itself. And we're going to talk about matters such as use of test hooks to make that possible. So first of all, there are some process improvements in terms of process, not just technical components, that make effective testing possible. And I'll put some up there. Not surprisingly, they align with a lot of requirements of this course. Writing tests first, requiring tests to be in place for pull requests, right? Regular refactoring of your system, dividing it up into modular units that can individually be tested rather than large hairball segments of code, which don't have a lot of boundaries where you can test that certain certain properties of the system. By spreading knowledge about the code base, you can aid testability because people are equipped with an understanding of what this does and how it's supposed to do it, and they can test it more effectively, right? So if you have people and inspections that learn about this area system, know what this is supposed to do and know what it needs to do its job, they can test it more effectively. Good naming and comments help as well, and up-to-date documentation. A lot of these things I will note Gen AI can help with. I mean, the documentation front it can help promote the better commenting, and certainly can help people give people ideas for effective refactoring. Okay, in this course, we're going to have quite an emphasis in over the next month or so in formal methods to enhance testability. This will include rigorous specifications of preconditions, postconditions, and for classes and interfaces, these higher level abstractions that include multiple functions or methods, testing things like invariance, particularly abstract invariance, as well as representation invariance, history properties, characterizing properties of the system. I'll call them algebraic, but they have to do with if you push and then pop, you get the same thing back, right? If you set and then get, you get the same thing back, the thing that you set it, right? If you set X and set Y and you read, you get Y back, not X, right? To give you very simple notions of what I mean by properties that have to do with different operations, that's what I mean. And that's a construct of an abstraction function we'll be talking about. The key point is, and we'll be spending quite a bit of time on these in coming weeks, that these provide the support for property-based testing. When I say property-based testing, what I'm talking about is not just giving an example and testing if you get the right answer back, right? That's what you do with tests, right? Give it this input and you see if it did the right thing. But doing the right thing for many tests traditionally is just seeing, did it give this certain output? Did it put it in this particular state? Property-based testing is about testing, did a certain property come about? For example, you sort an array, is it in ascending order, right? You undertake this, an insert of a new key into a dictionary, large dictionary structures that you've implemented. Is now the number of items in that dictionary one more than it was before this? The reason I emphasize property-based is it's no longer linked to one specific input. It's having a property and it can be generalized to actually test many, many different examples, including by randomizing examples, including by tracking down what is it about the example that's giving it a problem. You can do that with property-based testing in a way that is devilishly hard otherwise, or generally infeasible otherwise. We'll talk about that. Yes, Logan.
The question of property-based testing.
Yes.
Is it a complete separation from the case-based? Because it feels like there could be more difficulty in doing a good property-based testing that might have budgets.
It's more general. Yeah, it's more general. And the traditional case-based is going to, you have the specific, the term for case, and you're supposed to get this case of what result, right? Like what particular state you expect it to be. And that is generally, it's somewhat easier to think about, like you can derive it and specify it. Property-based testing requires thinking at a somewhat higher level, right? What the properties of this, like what is it supposed to guarantee about this that would hold not just for this case, but for many other cases, right? And what you're generally you're not always able to do that in a way that will ask, is it correct? But it's more, is it obviously not correct, right? Like, or making sure it's not obviously incorrect. I'll put it that way. You're checking, is it in a sane, is it a result that properly guarantees these certain broad features that should be present? And generally you can formulate those without too much trouble. asking, is it correct? And demonstrating, is it correct, is sometimes possible, but that requires a lot more reason. And it is possible, to do that in a lot of cases, but that requires a lot more. I'm not seeking that level where you're testing. It doesn't meet all the criteria for correctness, but I will be expecting you to ask, are the properties such that it rules out many incorrect cases? Yeah, was there a hand up over here? Okay, so I want to talk some concrete types of investments that help promote testability. Modular design. When I say modular, I'm talking about building a system out of pieces that are well defined and good boundaries between them, right? Good interfaces. And where those interfaces are well defined from their implementation. Generally speaking, it also, there's a high pricing of this together with separation of concern. So when we say it's modular, generally those different modules have different responsibilities. Like some may deal more with UI updates, some may deal more with back-end issues with the database, some may deal with back-end, load balancing issues or server management. Some may deal with servicing endpoints for incoming requests. There's different parts of the system in modular design. And by dividing up their responsibilities, you can focus in on testing certain responsibilities for certain ones of these through a well-defined. Are you tracking what I'm saying in general terms? Okay. Multi-level logging. When I say multi-level logging, what am I talking about? Anyone? Theo.
It could just be a simple, it's the severity of the log.
That's right. Yeah. So whether it's an outright error, for example, whether it's a warning, whether it's sort of a debug level thing, something you'd be interested in if you're debugging the system, whether it's info level. Are you familiar with systems that log like this? Sort of at different levels of kind of urgency and importance or different levels of significance of the message. So like you might at a high level be interested in broad actions the system do. It's connecting to a database, it's disconnecting to a database, it's firing off a query, etc. Whereas, if you're debugging, you might be interested in lower level activities within that. It's getting back to the result set, it's get about to iterate through it, it finished iterating through, and it's much lower level. By multi-level logging, I'm talking about ability to turn it on and off. Logan, did you have a comment there?
All I meant to say is I haven't encountered it before. A Python project during the summer for research.
Yeah, good. And you may know from that, pointer, a sector of some sort. I could point at this. I need to see if I can bring that. By multi-level logging, the idea is you can throttle forward and back how much detail you have in the logging, right? You can say right now we want to view things only at the very most urgent things, say warnings and errors. And later you may say, no, I'm in the midst of really trying to debug this issue or trying to speed up the performance. I want to see at a detailed level what's going on. And you can do that dynamically. What do I mean by dynamically? So Hawaii, yeah. Sorry? Well, here I'm actually talking not merely at a compiler level, at the level of build time, but also at the level of runtime. So like during runtime, while it's running, I can turn it up the level of logging, so the level of detail, and I can turn it down. So if I want to focus on one area of code for debugging, I can have very low logging for a while until I get to near that point for debugging. And then I crank it up and I can see lots of detail and I can start the, intensive debugging. And then crank it back if I'm past that point. Does that make sense? Okay. Assertion. Assertions here, these are sanity checks that my reasoning about the system is solid. When we talk about assertions in separate lectures, but basically I'm saying this is my understanding of what the case is. Maybe it's a precondition. Maybe it's at the end of what I'm doing, maybe it's a post condition, or maybe it's in the middle. I'm trying to reason about what's going on in the code, and I'm thinking about it, and you should just put down those thoughts as assertion. Is this the case? Is indeed this the case? As sanity checks for your thinking, because if you're off in your reasoning, almost you're bound to be off in the results. Right? If you're off in the reasoning along the way, Tyler. Yes.
I want to ask a question, but not assertions have anything to do with property-based testing.
Sorry?
Do assertions have? anything to do
Oh,
with
they have lots of things to do with property-based testing, very centrally, and thank you for highlighting that issue. Because property-based testing is confirming as you're running the system through test cases whether the results meet the properties expected of a successful result. Okay. And this is in contrast to case-based testing where you feed in this exact input and you get that exact output out. You're asking, does it meet the properties? And by testing that, you can generalize it much broader than one case, right? And you could give it random inputs and see, does it for every one of those, does it at least meet those properties, right? Assertions are testing properties too. They're testing, is the situation the system's in right now in line with my expectations? You're testing the logic, you're understanding the situation in terms of logical criteria. So you're testing properties along the way. But the assertions are doing so as the code runs, not so much in test harnesses that call the code and check these things. Does that make sense? Okay. Harnesses and drivers. What am I talking about? A test driver. A test driver. What do I mean by that? Okay. Yes, Logan. The Logans are strong.
A part of the code that can make the system think it's running with user input code, user input.
Yeah. So excellent. Yeah. So it's making the system run I'll say programmatically. What I mean by that is without user input, like automatically. It's driving this. So I do want to highlight this is an important point. I'm actually really happy with the level of interaction here. Thank you. Those who are contributing to this. And I really appreciate that. I also like the fact that people are taking notes. Okay. I will say quizzes are coming to this classroom soon, and those notes will help a lot. They'll also help for the final exam. I recognize that some people watch the video, etc., but notes are good, and I think you'll find them very helpful. Okay. Yeah. So with a harness, with a driver, we're putting the system through its cases. I said programmatically, meaning through code that drives it, that calls off to it and asks it to do things rather than a user, right? This isn't always possible at every level of the system, but even in an Oculus-based system, which may require some user driving to undertake certain tasks, for lower level pieces of it, for elements of the system design and implementation, you should be able to have drivers that will call off to them and test, are they operating correctly, or at least are they not operating obviously incorrect? Per my comments on property-based testing. So you'll call off to the system. Sometimes your config files that will set the system up in a certain state undertake some actions, perhaps give it different inputs as if it were coming from the user. So this team had asked about like MVC, model view controller type designs in there. One of the things of which I spoke with a modicum of enthusiasm was the fact that actually with profound enthusiasm, positively passionate about it, was the fact that by carving it up into model view controllers, you could swap in alternative controllers as if the user is undertaking certain UI tasks, or swap in alternative views that could do logging, something like that. And so here, often you want to test it with different inputs and you want to record output of some sort. Sometimes allowing multiple inputs on a client can allow multiple things to drive it. And stubs, mocks, and fakes. If I say stubs, mocks, and fakes, are those words have any significance to you? If I talk about those? Those are sort of okay, so those are I'm tempted to say placeholder. They're temporary components that go into a system, either because that part of the system has not yet been written, and there needs to be a kind of a placeholder that will handle some tasks so elements of the system elsewhere can test it, or they're put in place to test the system more thoroughly. And that's the job. That, folks, is the job of a mock. The mock will generally test properties. So, for example, maybe it should only be called once, this method. Maybe it should be called only with non-decreasing values over time. Maybe this component should be called once at the beginning, once at the end. A mock can check its arguments passed to it. It can check how many times it's called and with what arguments, and generally test whether its invocation by other code matches certain properties. Yes, Theo, you had your hand up. I kept you waiting. Apologies.
So question on that, so
Yeah.
if we have for example, we need an idea of a fully saturated Java class that isn't quite defined yet, but you want to test.
Yeah, you want to test other things that may depend on it, right? So you may have, this is where yonder camera will be so valuable. It follows my strides in admirable accuracy. Okay, so you have maybe different areas of the system. Maybe this is some area A, B, and C, and maybe these are classes or other things. And maybe you've implemented A and B, but they call not only off to each other, they call off to this thing C, which you haven't implemented yet, right? And you want to mock out things in here or stub out as this isn't implemented yet, so that they at least return placeholder values back to this so these things can be tested. But more significantly, Theo, is the fact that even if this is implemented, you could swap in. If this is calling through some sort of interface, so it's not hardwired to see the class, its instances of C itself, but just that C goes through a certain interface. All it knows is it's calling off to something through an interface. Then you can mock these out in ways that they think they're calling off to C. But really what's going on is C is mocked out. So it's returning sort of fake or mimicked values, representative values back. Maybe it's random values, maybe it's values that are fixed of some sort. But it's also checking what B is calling to it. It's checking that B is giving it sensible things to do and at the right time, that it's only calling it once, or that it only calls it once at the beginning, once at the end, or it calls it with values that fall within certain ranges, that meet certain properties, that the values it passes to it don't have duplicates in them, or they should only have non-negative values or whatever. You get my point?
Yeah.
Shouldn't have empty strings in it. Yeah. And it can do that in A and B are tested, right? Are being tested. And through that, you can develop confidence that A and B are working. Now, this phenomenon, we can imagine mocking out B and C. And there we'd be engaging in true unit testing of A. Like we're testing A, our focus is on A. And we're not testing B and C at the same time. We're using mocks for them. We're checking that A is we're developing confidence whether or not A is working properly. It's calling off to mocks of B and C. And that allows us to focus on if A is working. If we're testing A together with B and C, then we're really doing integration testing, right? We're testing all the three work properly. But if we want to test A properly with unit tests, we mock out B and C. It's sometimes called unit integration tests if we test like one thing together with the things that it's calling, but our focus isn't on the one thing. It's a form of integration testing. So we have sort of unit testing where it's ideally in isolation. The rest of the things are kind of mocked out or faked out. And there's unit integration where the focus is on A, but it's really a form of integration testing in the sense that it's calling off to B and C. And then full integration testing, really our focus is, do these things play together nicely? Are they consistent? Because the person who designed A, the person who designed B and C might each have had made very many sensible decisions. Each of them are consistent in their own terms, but they don't play together nicely. What A considers, I've used this example before, forgive me, but A considers a return value of 1 to mean success and 0 to mean failure, and B considers a return, if it passes, returns the value back to A of 1, it means failure, and 0 means success. Yes, Tyler. Oh, okay. Okay, so mocks, stubs, and fakes provide us this way of sort of having mimics for portions of the system that are temporary mimics. They're doppelgangers for these things that will let the calls here occur and check whether they are being made. Those calls are being made in sensible ways and return back sort of plausible or placeholder results, particularly so we can focus on testing certain components of the system. If we didn't do this, we might not be able to develop all that much confidence about whether A is calling B properly. This is our chance to see, is the way A is calling B, for example, by having this mock of B, is it testing it in a way that adheres to the requisite properties that B is expecting? Does this make sense to you? The notion of mocks? Now, if A is implemented and B and C are not yet implemented, we commonly talk about stubs, like there's just temporary components of B and C that we put in place, which are not really used to test A. They're used to kind of have temporary scaffolding so that A can get back values. It's just a stub is kind of like a temporary thing that isn't really designed for testing the calls to it. It's just there to allow those calls to take place to return. A fake is somewhere in between a mock and a stub. It may test some very simple properties. I do want to highlight that there are frameworks out there for mocking that are really good frameworks. But one of the key things you will do that will help you with mocking is putting into place separation of interface from implementation, calling things through interface. Because by calling things through interfaces, you're not hardwired to these things. You can swap them out, something else that meets the interface and checks those properties. Does this make sense? Are folks following this? Okay, I'm seeing some degree of nodding. Okay. Right. Crash reports. I don't know how much you folks are attuned to crash analytics. Is that ring a bell? there's a little cottage industry of tools for doing crash reporting and analytics associated with them. So every time your system throws an exception, crashes, it phones home with a report on what went wrong, what the state of the system was, where the error occurred, and it posts it often via HTTPS or some endpoint. It will post it, stick it in a database there, and then you have this whole record of how crashes occurred, where they occurred in the system, under what conditions, under what platforms. If you're using, an app, it has to run on Android and iOS, or if it has to run on laptops as well as mobile phones, where are the errors occurring, under what conditions, where in the program, Does that make sense? So there's sophisticated tools for this. Tooling that you can interface wire into your system so that you get that information automatically collected, and project managers, dev managers, test managers, a good activity for you is reviewing those, right? Figuring out where these errors are occurring. It's a good type of status report to get. How many crashes have we experienced from the test set, the test suite, within the past few days or whatever. It's great if you want to track down for debugging, right? Oh, the system crashed. Let's go see what was recorded, and you can test it. But I want to talk with you folks about hooks. Hooks are deliberately chosen components of your system that are temporary. When you build a building, I don't know if it does, the way construction takes place. When they build a large building here on campus or downtown, there's a lot of temporary structures that are built up with it. Scaffolding of various sorts, right? And that scaffolding looks a little bit different in different climes and different environments, but it's often quite large. And it's quite imposing, and it has to be built into the plane, like the scaffolding you put in place. Test hooks are like the scaffolding we put into place while building systems, okay? They're not a permanent part of that system that runs while the users run that system, but they provide ways of testing code to allow for testability, to enhance testability. Okay. And I'm going to give some examples of this. They allow us to better understand the current application state, and they may allow us to modify that state in some way to see the results of the system. For example, if your system has to be robust when it goes offline, maybe you're putting in place logic to handle offline access, and going offline. A test hook might actually ask your system to impose the state that it understands it's offline and see how it behaves. This prevents you from having to literally put your phone in an offline state to test it. You don't want to have to unplug an RJ45 Ethernet cord every time you want to test whether your system's going to crash when it goes offline, right? You want to be able to tell it, like, assume this condition is now in place, that the disk is full, is another good example. You don't want to have to, like, fill up a disk physically to test does it work if the disk is full. Or another example here, was it Gary who mentioned, like, out of memory conditions? You don't want to have to, like, literally starve your system for out of memory conditions, like, which would occur for example, for a memory leak. You want to be able to say, pretend that the system has, is very low in memory, and see how well it tests. So the whole province of what's called stress testing, I don't know if that's a name you've heard of. There's different sub areas of testing. One of them is what's called load testing. Here you're testing your system. Load testing, testing it under like large user loads, etc., intense bursts of activity. And then there's stress testing, where you're testing it under very slow network connection, very low memory condition, very low free disk space, high CPU contention, etc. And you're seeing, does it fail and how it fails. Does that make sense? Like when you put a system through this test, you want to make sure that when it's under pressure, it doesn't fail adversely. It's one of the cruel ironies of our job, of our fate is self-resolved. That some of the times where we most need to thrive or most need to shine are the times where our systems are most under stress. If you design a web app for a system and it's highly popular after release and people get really excited, they will flock to use it. And it will put the system under high load on those times. That is where it has to shine, right? You just unveiled it to the world. And this new site, this new music sharing site, or this new site to, offer this service. That's the time when the publicity is there and people flock to it. It most needs to be able to shine. It's the time where the most load is on it. And there's a massive difference between naive software developing where you're just trying to make it work and where you're making it work in a way that is safe under high load and safe under. That's another level of engineering to make sure and quality assurance to make sure it does well. So load testing and stress testing are whole areas of testing to make sure your system stays robust under challenging conditions. And there is tooling for that. So I remember consulting, in the 90s, for a company whose product line built tools for stress testing. And they could artificially induce conditions as if the system was out of memory or nearly out of memory or is low disk space and see if the system, the code base still functioned properly. Test hooks. Test hooks, properly done, often require very little amounts of additional coding. And there are times where, for testing in place, you might want to keep them not active, but available in shipped code for certain uses. There might be a subset of them that are. And they often improve really debuggability and the ability to better understand problems you're encountering with third-party code bases your system is using. So let's talk about test hooks. I want to make this fairly concrete. So some common types, right? Hooks for inspecting the internal state of the system. These are generally through privileged interfaces. These may unveil aspects of the implementation that you otherwise wouldn't want to unveil for abstraction reasons. And they allow test code to confirm these properties, like representation and that this system is in a sane state. This data structure is in a correct state. That has no duplicates, that has no there's no empty strings as its keys, that everything is in the proper ordering within it, etc. You may have certain diagnostic routines that make sure that everything is consistent across the system. In some cases, you may expose functionality to set and get things so that you can make sure that you are, if you put the system into a certain state, you can get out results from it. And in some cases, you inject errors. As I said, you tell the system to assume it's offline. You put it in a state where it thinks it's a really slow network. You put it in the state where it thinks it's out of memory or out of disk space. Driving the application, like an interface to drive the application independent of the UI, can be really useful. And sometimes you provide UI hooks into it as well. reading state of the application and setting aspects of it, application state. Here's here's a bunch of examples. Enable, disable logging of connections, memory usage, keystrokes, or what have you. Browsing of internal data structure, the capacity to browse an internal data structure. Maybe there are internal data structures where if you go through it manually in a debugger, not that I'd recommend GDB for it, but imagine going through things, it would be really tedious to go through this data structure, to explore it. Maybe you have a custom UI that will make it really easy. It'll print out aspects of the high-level structure of that and summarize the contents and give you a sense of what's in it, maybe even exhaustively enumerate the contents. Maybe even put them out as XML if that's a common need to then, process that and analyze whether it meets some criteria. So you may have a tool for doing this for some core data structures. To confirm the integrity of a data structure, this idea of like representation and variance will be very closely tied in with that. Checking on the intermediate state of an algorithm. Maybe you have an algorithm that's doing something quite complex, and you want to make sure the intermediate state is sane, that it meets some criteria, meets some properties. Custom command language, that goes along with sort of the idea of scripting it. Finding out about the connection state of the system. Remember, the UI provides this tiny straw level view of your system state. What you see through the UI may give you hints about some bad things that have occurred in some cases, but there's a lot of things which can occur that will remain hidden from the UI for a while. It may remain hidden for this entire session. It's saved to disk, saved to persistence layer, to the database, and only later it will come about in a later session. So you want to have ways of like knowing, is the system in the correct state now? Has it done the right thing? You might ask how much data has been sent. Has the system flushed its results to the database? Report the locks of the database that are currently taken out. And aspects of the state of the steps that have been taken. So I'd mentioned causing rare conditions. I put it in a certain state, simulating long delay conditions. So these are some ideas of test hooks. I'm just trying to get your creativity, in place. I see great significance in this class for testing. I see it for T1. You have this larger system with multiple layers and complex operation required, perhaps with offline access, the ability to access it from different types of application or different types of UI devices, types of devices. I think there's a big need for being able to make sure that it's working together properly, that it's doing the right thing in testing. And if you're just testing input-output, a lot can go wrong in the middle that will give the wrong output. If you can peek along the way, is the right thing happening? You can you can track problems down much sooner, debug it. You can also develop confidence. Is it working with a lot more confidence? For Team 2, Oculus or Meta Quest. There may be certain aspects of user interaction that you have a very difficult time driving programmatic. But you may be able to have, and you should, and I will implore, exhort, positively command you to get in place hooks so that when if there's actions that only the user can undertake, only through manual interaction with the Oculus, that someone through proper UI actions on the controllers or what have you, they can request certain outputs from the system, certain reports of what the system state is. They can change perhaps certain aspects of the system state to see if it operates properly. They can do things that wouldn't be enabled within the final system to make sure it's operating correctly. These aren't super hard to do. They just require you to think outside the box of what is the end user going to be able to do. got to start thinking about what will be useful for us as developers and especially testers to be able to do. What special things, if we could do it, will give us much more insight about what's going wrong or whether the state of the system is correct. Does that make sense? This idea? Yes, Logan, speak on, young man.
It does make sense. So this is a question from earlier on the previous slide.
Yeah.
On the left-hand side at the bottom.
This slide?
Or, yes, on the left-hand side on the bottom.
Yeah.
What's that one? Did we discuss?
This one?
Did we discuss that?
Yeah, well, I mentioned it briefly. So
Okay.
the idea is, if you have, if you have a system which is geared towards a single user, it may limit your ability to test it effectively. And it may be that if you could have a programmatic line of testing going on while a user is using that, for example, that would be better. So that you can run tests in place. This is this idea of multiple instances. The user is an instance, and then there's some sort of driven process that's running certain tests while the user is using it. Does that make sense?
It does.
And because that may allow it to be confirming as I'm going through manual test cases that it's working properly. It may be able to process logging output, if structured logging output from my manual testing to make sure it meets certain properties, that certain things are correct with it, that it's operating properly, right? So you may undertake certain actions in the MetaQuest. You may select certain things and so on, and it may report back, what's going on under the hood about this. Oh, it selected the cerebellum or whatever, right? And it's rotated this, by so many degrees or what have you, or it's deselected that, or now 3 things are selected, now 4 things are selected if you have multi-select or something like that. And that could be logged in a way that certain things are checked. That a previous group working on a MetaQuest project did that. So they had structured logging based messages, and they were running it through some sort of analyzer to say basically, did it do the right thing? And it doesn't just depend on the user to notice, oh, the cerebellum is not selected. It will verify it by checking those logs. Make sense?
Yeah.
It's easier on the testing. Yeah. Okay. Other questions? Yes, yes, welcome your questions. Yes, Logan.
What was the point that hooks might get reused by the UI?
Oh, yeah. There are times where the UI, you'll want to make UI widgets available to undertake certain of these actions. So I just spoke to with the office, like you might want to bind certain of the controllers, buttons to undertake a desktop. Right? And similarly, not for the end user, right? This is all about scaffolding on a building. The scaffolding will be removed by the time the building is commissioned. By the time the end users move into the building, there won't be all these poles and metal stuff on it. While it's being created, what can we provide in place that will make it easier to test by manual testers or automated? One part of that is binding things to the UI, so that when testers are running through it, they can push that button that will test, that certain sanity conditions still hold.
So it would be like menu.
Yeah, debug menu or a yes, you can think of it as a debug menu. It isn't always invoked after a problem has been found. It's about to try to know if there's a problem as well. That makes sense? So just my point in this is not to get you to do all these things. My point in this is to get you thinking, how can we proactively invest in making our system easier to test? By putting in place these sort of temporary scaffold, these temporary mechanisms that we will use to more quickly and more thoroughly and more reliably test the system into bugs. Think about those things on the different areas of this system, the back end, etc. Okay, multi-level logging, we've talked about it. Automated crash reports. I think you've got the basic idea. Modern systems do very impressive jobs with this. Oh, do you think with multi-level logging, I should have mentioned, multi-level logging can fruitfully be put out to multiple sources. You might think of logging as sort of flashing up in your console. But just remember, like it can be fruitfully put to a file, it can be put to a database, it can be posted. Once it's finished, it can be posted to a through a HTTP endpoint to record it at some sort of REST endpoint, etc. With crash reports too, like management of those crash reports, those are an asset. Those are something you want to manage. Those are something you want to collect, keep, and be able to ask questions about to assess quality and to be able to track down quality. Make sense? Okay. Think those. Yeah, I've talked about fakes, mocks, and stubs. Basically, mocks have the intelligence to look actively for problems. They're part of. Some people talk about defensive programming. Here in this class, we also talk about offensive programming. Not in the sense of being a dog, right? But we talk in the sense about taking the fight against bugs to the end, like going proactively after those bugs. Assertion, logging helps with this. Test hooks help with this. Putting in place mechanisms to root out the bugs close to where they occur. Not allowing them to just go on, and only later discover them through the UI much later, when it's quite distant from where they occurred. But getting them early, and assertions help with that, specifications help with it, hooks help with it, etc. Mocks help with this by isolating systems and verifying their properties at these interfaces to this, so that if A is doing something inappropriate, like calling things with arguments that are out of their proper range, or with arrays that are not properly bounded in terms of the elements in there, you find it as early as possible. Stubs again are sort of temporary code for a particular method, and fakes often they're really simplistic versions of mocks that aren't really testing much. But they may return simple values, etc. Okay. Yeah, key points of use for mocks: integration tests, unit testing of A, testing UI in some cases, like mocking out whole sections for the controller for the view, and verifying sequences of user operations, like actually recording what's going on along the way. Sometimes mocks, I should know, sometimes mocks stand in the way. Like you have mock here, it interposes here. This calls off to this passes it on. It's a pass through, but it checks the properties along the way. Does that make sense? And as it goes back, it checks the return value and goes back. It's interposed between. It intercedes between. Okay, and these help with debugging. Okay, yeah, I'll just note, and really we're running out of time here. Right. JMock is an older system that I saw some slides on, so I thought I'd put it up. The point is, it allows you to state declaratively expectations about what you expect. It builds the mock for you. It actually builds it up for you, so you don't have to implement the mock. It'll actually create it for you so that you can just use it. You say, I want to mock out this, and it'll create a doppelganger that checks expectations about what is the case, right? That checks whether an argument is null, checks whether one argument is the same as another, checks if it's equal to a certain value, and checks if it falls in within a certain range of possibilities, etc. So mocking is assisted by frameworks, just like crash data collection is assisted by frameworks, just like logging is assisted by frameworks, assertions. Use them early, use them often, use them ubiquitously. And I will enjoy a delightful review. Thank you. That's all for today.